Hi everyone, see you again. Are you ready for this video? Yeah, so let's start. Okay, we'll recap first about ISO 14046 from the previous video. On that video, we have explained about water footprint assessment, life cycle assessment, and about the principle. So, in this video, I will cover 6 topics, which is the general requirements, goals and scope definition, water footprint inventory analysis, water footprint impact assessment, interpretation on the result, and last but not least, limitation of water footprint. So now, let's move to first topic, which is the general requirements. Water footprint assessment addresses the potential environment impacts related to water associated with a product, process, or organization. They have 4 phases of life cycle assessment in water footprint assessment. Firstly, goal and scope definition. Secondly, water footprint inventory analysis. Next is water footprint impact assessment, and lastly, the interpretation of the result. While the 3 phases of life cycle assessment in water footprint inventory, which is goal and scope definition, water footprint inventory analysis, and interpretation of the result. For the goal and scope definition, focus on goal of study, which is about the intended application, the reason for carrying out the study, and the intended audience to whom the result of the study are intended to be reported. Goal of study also is stand-alone assessment or the part of a life cycle assessment, and the study is a part of life cycle assessment where comparative assertion is intended. In the scope of the study, the things should be considered in the scope of study is system boundary and organizational boundary, functional unit, temporal and geographical coverage, data and data quality requirements, cut-off criteria, allocation procedures, assumption, value choice and optional elements, water footprint impact assessment methodology, the result of the water footprint assessment, uncertainties and limitation, justification for exclusion from the study, baseline condition with which the current condition caused by the activities are being compared if applicable, and lastly, type of reporting and critical review. So now, we talk about the system boundary, where the system boundary determines which unit processes should be included within the water footprint assessment, and it should be clearly identified. Selection of the system boundary should be consistent with the goal of the study. The criteria used in establishing the system boundary should be identified and explained. System boundary for the water footprint assessment should indicate whether it's for a specific product, process, or organization. If water footprint is to be determined for a product, the requirements and guidelines of ISO 14044 on system boundary should be applied. But if water footprint assessment for an organization, the organizational boundary and the system boundary should be determined. Decision should be made regarding on unit process to include in the study, and the level of detail of the water footprint inventory analysis should be clear. Also, the input and the output should be included, and the level of detail of water footprint inventory analysis also should be clear stated. For data and data quality requirement, the data should be considered in data collection is the quantity of water used, type of water resources used, which is including for water withdrawal and water receiving body, data describing water quality, forms of water use, change in drainage, stream flow, groundwater flow, or water evaporation that arise from the land use change, land management activities, and other forms of water interception, location of water use, seasonal change in water flow, water withdrawal and release or change in water quality, temporal aspect of water use, including timing of water use and length of water storage. Data quality collection, which is primary data and secondary data. The things that consider for data quality is time-related coverage, geographical coverage, technology coverage, precision, completeness, representativeness, consistency, reproducibility, and source of the data, including models when used, and also uncertainty of the information. For missing data, the treatment of missing data should be documented. The importance of the missing data should be assessed. Offsetting. Water footprint result should not include offsetting. Offsetting is a machine for compensating the water footprint of a product, process, or organization through activities which reduce water impact in a process outside the boundary of the product system. So now, let's move to water footprint inventory analysis. Water footprint inventory calculation. Firstly is calculating. Explicitly documented, clear assumptions, and consistent. Next is validation, which is conducted during the process of data collection and involve establishing. Thirdly is relating, which is the quantitative input and output data of the unit process should be calculated in relation to this flow. Next is care, which is the aggregating the inputs and outputs consistent. And lastly is refining, which is reflecting the interactive nature of water footprint assessment based on a sensitivity analysis. So, next is procedure for water footprint inventory analysis. Firstly, you need to identify the goal and scope definition, which is allocation, includes reuse and recycle. Then, preparation for data collection. Next is validation of data, relating data to unit process. Next step is relating data to functional, data aggregation, and lastly refining the system boundary. Elementary flows may be directly collected from unit process or derived from data which represent material flow. In this elementary flow should be include input and output that consider for unit process being part of the system to be studied. Information on each elementary flow should generally include, where relevant, firstly, quantities of water used, which is mass or volume. Secondly, resource type of water used. Third, water quality parameters and characteristics. Next is form of water use. Then geographical location of water use or affected. Temporal aspect of water use, and lastly emission to air, water, and soil that impact to water quality. So now we move to the allocation in water footprint assessment, where it is necessary for product or service, processes, and organization guidance in ISO 14044 to assign the input and output of processes to the function. Other than that, they have specified goals and scope definition bases. And lastly, the sum of the allocated input and output of a unit process should be equal to the input and output of the unit process before allocation. So, for allocation procedure, firstly, you should avoid dividing the unit process to be allocated into two or more sub-processes, collecting the input and output data related to this sub-process. Next, cannot avoid, which is input and output to reflect the underlying physical relationship between them. And lastly, physical relationship. Input and output should be allocated between the product and function in a way that reflect others' relationship between them. For allocation procedure for reuse and recycling, you need to apply in water footprint assessment, recovery process between the original and subsequent product system that in allocation principle, reuse and recycle, composting, energy recovery process from raw material to disposal. For relation between product system and allocation procedure, you need to focus on product system, and then processing material. Next is recycle in the same product. If yes, you need to close loop product system and close loop allocation the procedure. But if no, you need to open loop product system and change in the inherent properties. And if no, you need to close loop allocation procedure. But if yes, you need to open loop allocation procedure. So now, let's move to water footprint assessment. Water footprint impact assessment compliant with ISO 14044, and then it also provide further requirement and guideline for assessing potential environmental impact related to water. When weighting is applied, it should be conducted and reported according to ISO 14044. For an example, water footprint indicator impact on water scarcity. Concept of category indicator illustrated for an impact category addressing water scarcity, which is life cycle inventory result, water input and output with indication of region and water body possibly together with elementary flow, which is impact category is water scarcity, and life cycle inventory result assigned to impact category, which is water input and output with indication of region and water body. Next is category indicator, which is contribution of water scarcity, and also the environmental relevance, which is category endpoint, which is human health, ecosystem quality and resource. So all of this is for environmental machine. Impact categories, category indicator and characterization models. Firstly, should be chosen based on the goals and scope of the study. Second, water footprint impact assessment method applied must be clearly described and documented. Thirdly, description should include environmental machines that are considered by the water footprint impact assessment method. Next, water footprint impact assessment method includes several category indicators related to environmental machines. Next is the naming of the impact category indicator should clearly express to which environmental machine it's referred. And lastly is as we can see, this is the graph that shows the concept of water footprint as a stand-alone assessment of part of a life cycle assessment. The impact for water footprint impact assessment example is water scarcity and water eutrophication, While for life cycle impact assessment, the impact category, the example is global warming and respiratory inorganic. Then is the characterization. Same also for the life cycle impact assessment. So next is normalization and weighting. Next, water footprint after weighting, and also lastly is water footprint interpretation. While for life cycle inventory analysis, the last stage is life cycle interpretation. For classification, if the calculation of the water footprint is based on different impact categories, life cycle inventory result should be assigned to these different impact categories, which is general. Method of calculating indicator result should be identified and documented. Water footprint impact assessment method should consider the potential environmental impact due to change in water quantity and or change in water quality caused by the system under the study. For geographical and temporal issue in characterization, water issue. Example, specific drainage basin, specific precipitation, hydrology, geographical characteristic and climatic, ecosystemic, socio-economic condition. And temporal aspect is seasonality. So now let we refresh back on methodological framework. Generally requirement, do you remember? Actually, general requirement, water footprint assessment addresses the potential environmental impact related to water associated with a product, process or organization. They have 4 phases of life cycle assessment, which is goal and scope definition, water footprint inventory analysis, water footprint impact assessment, and also interpretation of the result. For goal and scope definition, they have 5, which is goal of the study, scope of the study, system boundary, data quality requirement, and offsetting. While for water footprint inventory analysis, we have 3 parts, which is water footprint inventory calculation, elementary flows, and allocation. So next is water footprint impact assessment, which is general, selection of impact categories, category indicators, and also characterization model. Classification, water availability footprint, water footprint addressing water degradation, and lastly is water footprint profile. And also in this topic, I have shared to you about the life cycle assessment of water footprint inventory, which is have 3 phases, which is goal and scope definition, water footprint inventory analysis, and also interpretation of the result. So, do you want to know how to do the report of water footprint assessment? If yes, stay tuned for the next video. See you next time. Thank you for watching. Don't forget to follow us on Twitter and also our YouTube channel. Don't forget.